Hello YouTube, this is Canfer here. Today I want to show you how to build your own AM narrow FM receiver, step by step guide using GNU-RADIO companion. Let's start it up. This build I will use 22 blocks. I will use tune frequency, squelch active with a trigger chosen value, and RF gain and the mode selector. Blocks I will use today variables for sample rate and variables for decimation and variables for channel width, and we will use a low pass filter tabs and the QT GUI range for center frequency and for tune frequency and for RF gain and for squelch and volume, and we will use the QT GUI frequency sync and xlating FIR filter and the QT GUI sync and power squelch. Then we will use FM demode block and AGC2 and AM demode, and all these going to selector. After that multiply const, and finally to audio sync. Let's try it together to build this nice AM narrow FM receiver. Here I'm using Windows 10 64-bit. Now let's start a new QT GUI. We will use QT GUI here today, and let's start. Let's name it like new project AM narrow FM, and the title AM narrow FM, and the title let's name as what you like. Okay, right now we need this variable sample rate. Let's change the value to 1152000, 1.152 megahertz. Okay, right now we need right now another variable. Let's mark this variable as a channel width. And the value we need to make another variables like decimation, and we make variable sample rate. We need to put this in here in this value, int sample rate, and we want to add decimation, and close it. Okay, we see here right now it's tell us the value decimation cannot be evaluated, name decimation is not defined. Now we want to define a decimation right now, so we got another variable here and name it decimation, and put the value 72. As you can see here, the red line it's disappearing because we defined this variable decimation up. Now we need to add a low pass filter tabs, low pass filter. Tabs here. Okay, let's define the ID xlate LPF tabs. The gain is 1 and the sample rate, and the cutoff frequency, let's make it channel width with 2 channel width, and let's make a transition width channel width with 10. Okay, and beta 6.76. Okay, right now we need a QT GUI range. QT GUI range here. Okay, let's define it as a center frequency. And label it center frequency. Sorry. And let's make it more clear in megahertz. Right now let's make a type INT, and the default value, let's change it to 162, and start value 20, and the stop in 2000. Let's make sure the widget is make it counter, and the minimum length is 10. Okay. Okay, right now let's make another QT GUI range. Let's define it as a tune frequency. Okay, and label it a tune frequency. And let's make it more clear in kilohertz. And make the type INT, the default value 475, and the start minus 600, and the stop in 600. And let's make a steps 5 steps for tune frequency, and let's make it counter, and maximum length, let's put it 10. Okay, right now we need another QT GUI range here. Let's define it ID as a RF gain, and let's label it RF gain, and let's make sure the type is a float, and the default value, let's make it for RF gain is 10, and the start value 0, and stop up to 50, and make sure it's counter, and the minimum length, let's put 10. Okay, right now we need to define another QT range. Okay, let's define it ID squelch. and let's rename it for clearing as squelch. Let's make it to float, and the default value let's make it minus 55, and the start minus 100, and let's make a stop at 0, and steps 1 is good, and make it counter, and the maximum length is 10. Okay. Okay, right now we need to make another QT GUI range here, and we will define it as a volume and label it volume, and make it float, and the default value 25, and start from 0 and stop at 100, and the steps is 1, and make it counter, and minimum length 10. Okay, right now we need the QT GUI chooser block. Here. Okay, let's define it as a mode. So this block give us you can choose from narrowband FM to AM. Let's let's define it as a mode and label it as a mode. And it's integer, and number options we need 2, because we have a narrow FM and AM. We have 2 integers. Okay, 00 label 0, let's make it FM, and label 1, let's make it AM, and let's make it a combo box. It's okay. Okay, right now we need to source rtl-sdr source block. rtl-sdr source. Okay, let's put it here. Okay, it's the ID rtl-sdr source 0, complex float 32, and let's make it more clear here. Okay, sync don't sync, number in board 1, default blah blah blah, sample rate, it's a sample rate, and here channel 0 frequency, let's change into center frequency. That what we define ID. And let's make it 1 E6. And the offset mode, make sure to make it automatic offset, and this off and this manual, and the channel 0 RF gain, we need to change it to RF gain ID, and the IF gain here 2020. Everything's good right now here. Okay. Okay, right now we need another block. It's a QT GUI frequency sync. Let's put it here, and it's ID is QT GUI frequency sync 0, and it's complex, and let's name it as a RF spectrum. Okay, the FFT size is 1024, and the window type is black man. Let's define the center frequency. So let's make it center. Center frequency and 1 E6 and bandwidth sample rate, and let's change the Y minimum to -90 and the Y maximum to -20, and Y label relative gain dB1. Okay, right now it's okay. Okay, right now we need the frequency xlating FIR filter. Okay, it's a frequency ID, frequency xlating FIR filter. It's make sure it's complex tabs, and the decimation, let's define it as a decimation. And the tabs, let's make xlate and LPF tabs. And the center frequency, let's make it tune frequency. (1E3), and the sample rates, it's good sample rates. Okay. Right now we need QT GUI sync. The ID QT GUI sync 0, it's complex, and the name, let's name it as a channel spectrum. Okay, the FFT size is 1024, is good. And the center frequency, let's define it as a center frequency and tune frequency. Okay, let's define it as a center. Frequency one E6 plus tune frequency one E3. Let's close it, and the bandwidth, let's change it to channel width. Okay, and the update rate is 10, and this is blah blah blah. Show RF frequency. Yes, it's so. Make sure we want to show this RF frequency. And the plot time, we don't need a plot time, let's make it off. And the plot const, let's make it off. Okay. Okay, wait, now we need another block, power squelch block. In power squelch clock, let's make it threshold squelch. and the alpha 1e minus 4, and the ramp is 0, and the gate is yes. Okay, right now we need the FM demod. Let's put it here. Let's define it channel rate as a channel width. And the audio decimation 1, and the deviation, let's change it to 5000 is good, and the audio pass to 3000, and audio stop to 4000, and again is 1, and the TAU is 75E minus 6, it's good. Okay, now we need another AGC2 block. Let's name it analog AGC2 blah blah blah, it's okay, and the attack rate is okay, and difference is okay, and gains, everything is okay here. Okay, we need right now AM demod. Okay, let's put AM demod here. In AM demod, let's define the channel rate as a channel width. And the audio decimation, let's make it 1, and the audio pass, let's change it from 5000 to 3000, and the audio stop to 4000. Okay, right now we need another block, it's called the selector block. Let's put the selector block here. Let's make the type, change it to make sure it's a float, and the number input 2 and number output, let's change it to 1, and the input index, let's make it to mode, and the vic link is 1 and the output index is 0, it's okay. Okay, right now we need multiply const. For volume, let's make it float, and constant, let's make it volume. .0, and vic length is 1. Okay, right now we need the final step is the audio sync. Let's put audio sync here. Audio sync 0. We need to change this sample rate by delete this and make it a channel width. see. Okay, right now we finish all 22 blocks. Now let's make all these together, connect all these blocks together from rtl-sdr source output to QT GUI frequency sync, and another from rtl-sdr source output to frequency xlating FIR filter, as you can see here. Now right now from frequency xlating FIR filter to power squelch, and another from frequency xlating FIR filter to QT GUI sync. And right now from power squelch out to FM demod, as you can see. And right now from FM demod to selector, and another one from FM demod here to from the selector here. Let's make it to multiply const, and from multiply const here to audio sync. Okay, and we have another from power squelch here to the AGC, and from AGC to AM mode, and from the AM mode to selector, as you can see right now here. Everything is together right now. Let's generate the flow graph here. Let's name it as AM-FM test 2 GRC to desktop, and save it. Right now let's generate a Python file here by clicking here. Right now let's start this up. As you can see here. Now let's from here the mode you can select AM and FM. Let's try to put a specific frequency like for 2-3 megahertz. As you can see here. Let's try the tune frequency to catch this signal -75. As you can see right now, the trigger for squelch is right now deactivated, and you hear the signal here. Let's try to change it from this mode to AM. As you can see right now it's in AM mode and in FM mode. As you can see, you catch the narrowband frequency here, maybe a repeater or something else. Let's try the waterfall. As you can see, change the color here. Frequency display. This is for active the squelch level here. Let's try to change the frequency, tune frequency. Let's make it for 2-3 megahertz. As you can see, the squelch right now is active, and so we not hear anything. The squelch is active. Okay, nice AM-FM demodulation here. Okay, YouTube, this is Kanfar here. Thank you for watching, and stay tuned for another step-by-step GNU radio blocks tutorials. Thank you for watching. Bye bye.